Hello and welcome to this presentation on ISEG and W-IE-NER Power Supply modules. In this video we will take a look at how to get started with the hardened software. The first step will be to install the modules in your Mpod crate. If your Mpod is equipped with an Mpod C controller, it must be configured by using the Muse Control software. If the CC24 crate controller is used instead, it can be configured over its web interface. We will enable its SNMP mode to make sure it's fully compatible to the Mpod C controller. We will use Easy LV HV for both type of controllers. Other software options are also available. We will shortly introduce them here. The Mpod crate and the modules are shipped separately, so the first thing to do is to install the modules. Thanks to the excellent mechanical build quality and compact form factor, this should not be a problem. Here we are inserting a 16-channel high-precision ISEG EHS. The rear side contains the connector for the backplane, a sticker with the serial number, and a jumper that allows to disable the safety loop. After having tightened the screws, we insert a W-IE-NER low voltage MPV module. These modules too are very compact and efficiently shielded. The rear panel connectors are different from the high voltage connectors, as the low voltage modules are powered directly from 230 volts. Essential information such as a serial number and a part number have been labeled. If the Mpod is equipped with an Mpod C controller, we must configure its IP address and other basic parameters using the Muse Control software. Muse Control automatically detects an Mpod that has been connected to an USB port of your computer. This makes sure that important parameters can only be changed by having physical access to the crate. The system configuration allows to adjust the IP address, configure DHCP, and enable or disable hardware interlock. To make sure Easy LV HV can communicate with the CC24 controller, we need to configure it accordingly. We connect to its web interface. We select the ICS config tab. First we make sure the hardware page reports no errors. Then we go to the SNMP page. There we regenerate the SNMP configuration and restart the service. Now both of our crates are ready to be controlled from Easy LV HV. On the connection page we enter the IP addresses of the crate controllers. If we enter an asterisk instead of the last number, the IP space is scanned. After a while our two crates are detected. With a double click we can add each of them to the list of controlled hardware. If System is selected in the hardware browser, the channel list shows all available channels. From here, Set can be defined for all channels at once. It is also possible to switch all channels on simultaneously. Now we will find out how to use the sense lines for low voltage modules. We have connected our load to channel 4 of the 8V MPV module. We must select this channel with a double click in the hardware browser. We switch the channel on and ramp up to 5 volts. We can see that for a current of 1 ampere the terminal voltage corresponds to the measured voltage. That means that the sense lines are internally connected to the terminal. We can change that from the Properties page. Immediately we see that the voltage drop in the cable is compensated by raising the terminal voltage. We raise the current even further. The measured voltage stays stable, but the terminal voltage is raised to compensate the losses. After a while, an error is raised and the channel is shut down. We can check the messages page for further details and also annotate these messages to the graph. The flags page shows which hardware flags were raised by the event. We realize that the current got too high. When checking the various supervision settings in the Properties page, we realize that the maximum current of 4.5 ampere was programmed. We need to clear the error if we want to switch the channel back on. 3 different modes are available for the sense line configuration. One of these modes should be selected depending on the length of the supply cable. We use an oscilloscope to find out how this affects the regulation. Therefore we have connected a load that will switch from 1 ampere to 3 ampere and back. We can see that the regulation reacts quickly if the fast mode is selected. This mode is probably not ideal for our 5-meter cable. If moderate regulation is selected, the regulation is slower. This is the most appropriate way to configure sense lines in our case. If slow regulation is selected, the regulation process is slow enough to avoid all kind of overshoot and oscillation. W-IE-NER MPV modules have many possibilities to protect the connected electronics, but also the power supply itself. These possibilities are referred to as channel supervision. When using Easy LV HV, the channel supervision options are available from the Properties page. Here we have programmed the channel 4 to switch off if the current exceeds 4.5 ampere. We increase the output current and notice that the channel shutdown works as expected. All events created by channel supervision will set a flag that allows to analyze the error. Check the flags page for more information on that. W-IE-NER MPV modules allow to define groups of low voltage channels. These groups can be switched off together when a supervision event occurs. We can see in the Properties page that channel 4 is in group 2. By selecting the appropriate option, we make sure that the entire group is switched off if the maximum allowed current is exceeded for channel 4. Now we check the other channels. We make sure that some channels of both modules belong to the group 2. We switch all channels on. Now we increase the current on channel 4 until it gets too high. All channels in group 2 are switched off. However, only channel 4 has the error flag set. Now we will switch to the ISEG high voltage modules and show some of their features. It can be very important to control the voltage ramp speeds. Some detectors don't like sharp voltage rises, so it needs to be really low. For some applications, fast changes are required, so we want to set it to the maximum. Low ramp speeds are not a problem, but setting the maximum is not always possible. The voltage ramp speed is limited if the current trip functionality is active for at least one of the channels of the high voltage modules. Here we are ramping up channel 2. First, this is really slow. Then we go to the module properties and change the voltage ramp speed to 5%. We can see immediately that the voltage ramps up much faster. However, when we go back to channel 2 and define a delay trip action, the ramp speed is limited to 1% immediately. Now we want to use the delayed trip action. This functionality makes sure that the channel is switched off if the current limit defined by Set is reached. For this example, we will ramp down once the delayed trip is active. We will wait for 4 seconds before the trip is triggered. We have a constant load here, therefore we simply change Set to trigger a delayed trip action. Sometime later the channel is switched off and the trip flag is set. We can see that 4 seconds have passed since having changed Set. ISEG modules allow to set a hardware voltage limit by adjusting a potentiometer on the front panel. Here we have ramped up to 1000 volts, which is the nominal voltage of the module. We can see in the properties page that the hardware voltage limit is slightly higher. At module level, the hardware voltage limit is defined as a percentage. Now we turn the potentiometer and see what happens. We can see that the hardware voltage limit is reduced. The measured voltage drops at the same time and the V-limit flag is set. In a channel list, Set values above the voltage limit are no longer accepted. Hopefully you will never have to use the emergency off function. However, here is how it works. By clicking on the emergency off button, all channels are switched off without a ramp. The corresponding flag is set on the concerned channels. To switch the channels back on, 2 actions are required. First, the emergency has to be cleared, then the channel flags have to be cleared too. It is important to remember that the emergency button only acts on the currently selected hardware. This can be the system, the crate, a module or a channel. Depending on your application, it might be a good idea to adjust the units used for the set and the measured current. Here we have microampere, which is not ideal. If we show the configuration page, we will see that these units can be configured. We select milliampere for the set current and nanoampere for the measured current. Always click on Accept Changes to validate a new configuration. As we can see, the units in the channel list and the graph window have been adjusted. We have used Easy LV HV for this presentation, but other software options are also available. You can use ISEG SNMP control if you have a single crate. For the CC24 controller, ISEG Control 2 might be an option. You don't need to activate SNMP for ISEG Control 2. If you plan to make your own control software, you should test the NetSNMP library. It comes with a series of console tools and has been integrated successfully many times. We hope that this presentation has given you some hints on how to get started with your ISEG and W-IE-NER hardware. We have planned and realized some more specific video tutorials. Don't hesitate to contact our support if you're interested by some topics that weren't discussed here. Don't hesitate to contact us for all hard or software related questions. Contact ISEG for questions related to high voltage modules. Contact W-IE-NER for low voltage modules and Mpod crates. Contact Physical Instruments if you are based in France, and Analog Flavor if you have questions related to the used control software Easy LV HV.